Right, so the only problem that we still have is we get an error here on this instruction here, which is a move line back singles. And I think from here, when executing an SSE instruction, we are required to be 16 bytes aligned. But if we go back to our debugger here, we can see that at this point, when we try to execute this instruction here, RSP plus 0x50 is clearly not 16 bytes aligned. It's 8 bytes aligned, but not 16 bytes aligned. So I think we need to massage our stack to be 16 bytes aligned when we get to our stack handler or interrupt handler. So let me try to do that. So that should be here. And so right, just before this call here. Yeah, so basically I've written this here, but now we are going to need to do that. So what's the quickest way to align this stack to 16 bits? I guess first of all we need to save it. Sure. Then we need to so let's remember that the stack grows upwards. So now that I've pushed this, if I need to basically round it down, so the stack here would probably be something like some ABCD number that ends with an 8, since it's 8 bytes aligned. If it ends with a 0 here, that means we are 16 bytes aligned. But here, we should probably be ending with an 8. So that means that I need to bring this to 0xABCD, or bring it up to ABCD 0, since we are rounding down. And I guess the easier way to do this is to just put another value in there. Let's put the value in RSP, and we end it with so basically 1 2 3 4 4 1 2 3 4 1 2 3 0, this value here, which is basically just minus 0x10 minus 16 minus 16. So I guess we would like to do minus 0x10 with RSP. And then here we need to restore the stack. So we need to move, I guess this needs a dollar in front of it. So this offset of RSP, so RSP plus, so the current stack plus 8 bytes, to RSP, I think. So we need to debug this, but there's still one more thing that we need to take a look at. So here what we do is we push Q, we push the error code, and we also push the vector onto the stack. So we need to actually get rid of those things before we return. We need to put the stack back to its original shape. So I guess we need to subtract 16 bytes from RSP. That sounds okay. No, we need to add to it. Add into RSP means pushing it down. Means we get things off the stack. Yeah, okay. Same goes here. So this one, we add the 8 offsets to push the stack down to get things off the stack. And here we move it upwards. We basically, yeah, okay, I think that's fine. We are going to need to build this probably. Do offsets not need this? Okay. I will never understand AT&T syntax. Let's just leave it at that. I'd even say I don't want to understand it. But yeah, that's just me. Okay, so let's take a look at our, did we call it common ISR, I think? Yeah, okay. Common ISR. IRS. Yeah, we should have quite a few of those. So let's whoops. There we go. So here we push that and the stack with all Fs, but the very last one, so that we can have it aligned to 16 bytes. We call our dispatch and then we put it back the way it was. Okay, that looks not too bad. So let me just copy that. Actually, let me do the option dump thing here again, and this time do less and look for common ISR. And actually we want to look for C03 D5. C03 D502. There we go. That was easy, I think. Right, so let's now go to our debugger. I'm just going to exit and rerun it just in case. I'll get remote 1, 2, 3, 4. Let's get our symbols, kernel 64, and let's hardware break on this address here. Let's also hardware break on dispatch interrupt, and let's go. Okay, so now we have our breakpoint here just before we start messing with the stack. Let's take a look at our stack. So our stack is currently aligned to 16 bytes. Yeah. So now we should go next instruction. Now our stack is not aligned anymore, and we've saved our stack pointer to our stack. Now, next instruction again. So now we saved the second time our stack pointed to our stack, and this time here we are going to force it to become aligned. So let's next instruction that, and there we go. So now our stack is forced to become aligned. Although, yeah, okay, that's fine. So let's go next instruction again. And here I'd like to print context. Okay, that's fine. So if we go next, yeah, if we go next, so hold on a minute. I actually want to go and put a breakpoint in our login routine. So, so hardware break at logger.zig log function. So maybe we should just go and find logger.zig. Whoops, it was right there. Line 13. Sure. And no, let's just next. Go next here. Our RSP is still 16 bytes line, that's fine. And now we go into our logger. Our breakpoint has triggered. And now we should probably take a look at what instructions we are trying to execute here. So the one instruction we need to pay close attention to is the move APS here. So let me just get this, put a breakpoint onto this address here, and continue. So as we can see now, our RSP is still aligned. So in theory here, we should not get an exception or a general protection exception from this. So let's just continue, I guess. And would you look at that? Did we actually get the message we wanted? Yes, we did. There we go. So we have interrupt context with the pointer of that interrupt. Great. So now what I want to take a look at is actually just after we exit the dispatch handler, I want to make sure that this code here is starting from this and going all the way down, that it basically puts the stack back to its original shape. So here I want to look for iret. Okay, that's not really what we want to do. So let's look for dispatch interrupt. I have not found dispatch. No, still not. Okay. So enqueue. Okay. Let's look for common ISR. Common ISR. Okay, so you should be able to find it. Okay, so let's go to right about here, 5. There we go. Cool. Not really, but okay. Right, so this is where we want to put a breakpoint. So right after the call to this. Or actually, let's put a breakpoint, somewhere here, just right on the call. And then I'm going to just info breakpoint and probably delete all of them. All right, so hardware break on this. Whoops, it's not what we wished for. Right, okay. File build kernel 64.elf and then hardware break on this address, please, and let's go. Cool. So now we are on the call. Let's just go next instruction. Oh, right. We have a hold. That's no bueno. Okay, let's rebuild this again. And let's retry to, or rather try to re-find where we, so common ISR, have that. Actually, let's just take a look at the, okay, it does not do that. Can only search from top to bottom. Okay, and the next one would be this one. That's fine. Now, okay, so target remote that. So it reread the symbols. We are going to delete the breakpoint. So delete 5 and hardware break on 0x. Do we not get that? 0x, this. Cool, let's go. All right, so now we are on the call. Very nice. So next instruction. Let's go. Right, so here we are on the move again. I should have probably put my breakpoint a bit earlier than that. But I think this is the value that we want. F48. Yeah, I think so. So next instruction here, we should probably go back to F48, and that is correct. So we have reset our stack to where it should be. Now, I would like to go to here to the to this instruction here. So let's just copy that. Just a normal breakpoint, software breakpoint there, and continue. Should not be too long. And now we are on the add. Now, the RSP is pointing to 14, to value 14. which is our vector. Yeah, it is our vector. We were in a 14-page fault. Yeah, that's the interrupt we've triggered. So that's the fault we triggered. So it's pointing to 14. So now 14 is 8 bytes. And after that, we have a 0, which is our fake code that we've put. And this add here should basically collapse those two. So if we go next instruction just before the iret, we should have, yeah, so we have collapsed those two. And now this one here points to the RIP that brought us here, which is, let's take a look again at this, because I think we have messed something up, but okay, that's fine. So that's okay. So no, we are interested in not the shadow stack. We want 64-bit interrupt handling. There we go. Right, there we go. So here we have the RIP. This is where we are on our stack currently. So now what I want to know is, so this error code might not exist. So for a lot of the interrupts that we get, this error code is not pushed onto the stack. What I want to know is, are we supposed to remove it from the stack ourselves? So iret, before we do the iret, does iret need to see the RIP, or does it need to see the RIP and the error code? So RIP pops SS RSP unconditionally off the interrupt stack frame. Okay, all right, that's fine. There we go. All this to just find this one single phrase here. So to keep the stack aligned for double word pushes the upper half, blah, 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 that's fine. Note that the error code is not popped when the art instruction is executed. So the handler must remove the error code before executing a return. So what we did, I think, is fine. Because I've written this add 16 to RSP before I thought about the fact that error codes were not always pushed by us. But with that, I think we should be pretty fine, I think. So here, I'm going to do a continue, and it should re-trigger the same interrupt. And yeah, it will just keep on going. Well, that was a long and windy road. Not sure how much of this will end up in the final edit. I'm pretty sure I will have cut out quite a bit, but we have a working GT, IDT, TSS, and architecture-specific interrupt handler. We now just need to actually handle the interrupts. As always, thank you for watching. If you've liked this type of content, hit like, subscribe, and if you have questions, remarks, or you just want to say hi, leave a comment down below. I highly appreciate those. It's time for me to step out into the sun. FLCNOS out.